All right, so in this video, I'm actually going to be going over Lab 10. And what Lab 10 kind of entails is where we're going to be practicing recursion, which is where a function calls itself. And I'm going to go into explaining what recursion is, base case, as well as a recursive case. And this is going to be a little bit more lengthier than in class, so I can take a bit more time to explain this to you. If you were in person, I did give a handout that you would use for this. If you weren't in person, what you would do is just download this PDF and you will see a file like this. Uh, and this file pretty much, this assignment was meant to be interactive and also giving you a little bit more instructions. And it kind of guides you on the thought process of each. So in class, students were given an opportunity to work on this to be able to come up with the first two in their own words for exercise 1, what they feel their understanding of recursion is, what a base case is, and what a recursive case is. So just simply saying the same as up is not going to be good enough. It needs to be in your own words. And then in the second one, it kind of shows you what a factorial function is, or at least a general overview of what it would be like. But if we were to pass in the factorial of 4 in this case, and how we would be able to write what would be the output, or at least tracing through that process. And this was meant to help you kind of go through and understanding what happens layer by layer for each function call when we pass in 4 into a factorial function here to initialize it. The next part of this, what we go into, is actually what it would be like to have an iterative factorial versus a recursive factorial here. And so I gave students, again, enough time to be able to try their hand at writing both before we went over them at the end of class. So everything from exercise 3 all the way down showcases the factorial function in a little bit more depth on both iterative and recursive function. All right. So in this case, we're going to go through each exercise that I went through in class, and this video is simply just for individuals who were not able to come to class on either of the days that I went over this assignment. Or if you just wanted to refresh the information that was given. All right. So the very first question that we're going to go through, and I'm going to code it through Zybooks. Or through Visual Studio Code, pardon me. And then what we're actually going to do is go through each item section by section. For this, if you scroll down to the bottom, you can either print this out and write it in if you were not in class with the handout, or you can actually just write it as a Pi file and submit that. And so in this case, we're just going to start here, but I'm going to go through a Pi file. So I'm going to set up my desktop screen so that you can see both, and then we'll go through each item. All right, so in this case, I have my Visual Studio Code pulled up here. And I know that we kind of did a little recursive exercise prior to this where I kind of went through the whole entire streamlet and explained to you like the 1, 2, 3, or 3, 2, 1 blast off and what recursion is. But this one is just so that you can understand the comparative difference between recursion and also iterative functions. So the very first thing we're going to do in Visual Studio Code is here we're going to add a file, and I'm just going to have it or label it lab 10 underscore recur versus iter underscore iter. And I'm going to do .py here. You can just, as long as you label it something that you can understand or remember to go back to or refer to. So in the very first case, what we're going to do, for question 1 or exercise 1, if you need to pause the video, feel free to pause the video. But in your own words, what I would like is for you to explain what a base case is and also explain what a recursive call or case is in your own words. This is going to be very helpful for you to retain the understanding of what is a recursive function, as well as the different components of a recursive function, which will be at least in a test on the exam. So putting it in your own words will help you quicker be able to describe it on the exam. So putting something like the same as above isn't really going to be helpful, and it's not the point of this exercise. So in the very first thing here, what I'm going to go through with you is what recursion is. So recursion is a way to solve a big picture problem. You can solve a smaller version of the exact same problem and keep doing that until it's so small you can answer it directly, right? So in this case here, when we're looking at what a base case is, what we're actually paying attention to is the base case is going to be, and here I have it stops the function, but in more depth, the base case is just the simplest version of the problem where the function can actually return a result without calling itself again. So it actually prevents the infinite recursion which some individuals were able to run into while they were working on their assignment or project. And this tells the function when to actually stop. So it prevents that infinite recursion, and it also allows your function to stop. So it's a call within itself. And recursion has two cases here. The base case, again, like I said, is the simplest version of that problem. The second case that we're going to look at is the recursive case. This is the part of the function where it solves a smaller or more simpler version of the exact same problem by calling itself. And you'll see a few of the examples that we get through later on, and even using lists and also just basic recursive functions as well. So hopefully you get a little bit of exposure of more easy functions versus harder functions, and it'll help you understand what recursion is. So for the very first question that we go through here, I'm just going to define what I believe a recursive base case is, as well as a recursive case is. And again, in the instructions, I kind of made it a little hints in what I'm giving you so that it helps you kind of guide you to understand what you need to do. So the very first thing I'm going to do is I'm going to have define, and in this case, I'm just going to do explain underscore recursion. And again, this should be in your own words, right? So in this case here, we can do a pass, and we can actually make it into a docstring if you prefer to do that, or you can do the prints as they have here. So the first thing you want to do, just to be able to, for your own remembrance, is write what you think recursion is, or what, in your own words, recursion is to you. And so in this case here, I'm just going to say, to solve this big problem, I'll solve a smaller version of the same problem, and I'm going to keep doing that until it's so small I can answer it directly. Spell that right. All right, so that is what recursion is in my own words. I know here, I've mentioned it before. It's a way for you to solve smaller or a big problem and break it down into smaller problems, but let this be in your own words. Now, the next thing we want to understand is what the base case is. And we want this to be, again, in your own words. What is a base case? So in this case here, I'm just going to put base case, the simplest version of the problem. I'll put where function can return a result without calling itself again. So this is the direct one. I'm going to go ahead and enter this out. Another thing that I'm going to note, because if I'm just hearing this for the first time, I want to know why it makes sense to have it or what's the importance of it. It prevents infinite recursion, and it tells, yep, it tells the function when to stop. All right, and I'm making it something that if I go back and read this later on, for example, if you're studying for the exam, you have generally a good idea what each of these are, and you're not scrambling to try to figure it out, because these are points that you, easy points that you could get, especially as we've walked through this in class. So in this case, now we've gone through what a base case is in my own words. The next thing I'm going to do is have what a recursive case is in my own words. So here I will just say the part of the function where it solves a smaller or simpler, let's see, yep, version of the same problem by calling itself. Down there. And this is going to be important for you to remember. This one calls itself. This one stops the loop and prevents infinite recursion. What is recursion? It solves a bigger problem, and it also it solves it in smaller versions until it's so small you can answer the answer directly. So now that you have this kind of understanding of recursion, what recursion is, you've explained it in your own words, expanding potentially on what you better understand or retain. Now we can move on to exercise or question number 2. Now, in this case, when we go through question number 2, factorial is one of those recursive functions that we pretty much use often to teach. It's not as efficient as the iterative function, but it is easier to understand because it is closer to the mathematical definition of factorial. Of what factorial is. And again, it's good for teaching and also understanding recursion. And it's used when the problem, if you're using the recursive version, when the problem naturally breaks into smaller sub-problems, like I mentioned earlier. And we will get into that here in one moment. All right. So in this case here, when we're looking at factorial function passing in 4, what we're actually looking at, I'm just going to do def q2 colon here. Or actually the function, let me move this out of the way so we can actually see what it says. So in this case here for question 2, this is an example code of what you would be looking at if we're using factorial here. We have if n is equivalent to 1, we're going to print out 1 or return 1 as a string. Here we're just going to look at the results of what n is times this function call here, where we're expanding the factorial from n minus 1. So this is essentially the factorial recursive call here, but it's using more prints as opposed to if we were just structuring it to return and do recursive call. We're looking more at it printing, and it is recursively calling here, and we do have a base case here. What is the process if we're passing in 4 as the factorial function? So here in this case, what I'm going to do is I'm going to use the same function that they have here, the function name. So I'm going to use expand underscore factorial. And I'm just going to have n minus 1 as what gets passed in here. And here I'm just going to assign n to being 4. All right, pop this here. oops, actually, this is just going to be n, and then here with the call, we're going to do 4 minus, or n minus 1 here. Copy the call underneath. There we go. All right. So when we look at what factorial is, and I've mentioned this a few times in class, but I'm going to go ahead and showcase to you what that looks like. When we're looking at factorial, what we're looking at is n. Explanation point is what you'll see, but it's going to be n times n minus 1. Each time, this is the mathematical expression of it, and then we're going to do that, and it's going to keep on going process over and over again. If we were looking at it by using our example 4 here, we have 4 factorial. We would have 4 times 3 times 2 times 1. That is what n factorial is, right? So this is the process. When we do n factorial or 4 factorial, we know the result of 4 factorial should be 24. But now what I'm actually wanting you to do here is structure what that would look like. And I went through this example in class, but I'm going to go through it here in this code process. So in the very first call here, when we're using n factorial, we're passing in 4. We know that's the example. I'm going to use doc strings here. But in this case, what we're going to do is with this exponent factorial, what I want you to do is start with what you pass in. So we start right here in this section. So we're going to pass in 4. The first time we pass in 4 here, the process is going to look similar to this. So we're going to have 4 when it calls this again, times, and then here we have our expand 4 factorial. So this original one, when we call it here, when we call it here with expand underscore factorial to initiate the call, like we do with main, we're going to take the value that we stored in the variable n and we're going to pass it in, and we're going to see it happen here. So initially, this is where it starts with the call. Now here, we're going to pass it in, and it's going to be this process here. It's going to check, is n equivalent to 1? It's not. And the reason why this is the base case here is because when we do any sort of factorial, for example, even if we did here 5 factorial or 100 factorial, it would just be 5 times the number before times the number before every digit minus 1 times 2 times 1. We know that the end process is going to be that one value there, or that one number. So this is going to be the base case. We know when we return 1, then the recursive call backwards is going to do 1 times this times this times this. So we know the base case here is if n is equivalent to 1, then we're at the end. So since 4 at the first initial call here is not equivalent to 1, what we're going to do is we're going to have your nth value, which is 4, times, and we're going to call our expand underscore factorial function, and we're going to do 4 minus 1. That's where that n minus 1 is coming from. So essentially, what is happening here, and I'm going to go ahead and put this over here so you can see it, is 4 minus 1 as an expression is going to actually be 3. Okay? So in this case, when we see that when we pass this in and it's 4 times the expand underscore factorial 4 minus 1 function call, we're going to now go ahead and go to the next process. So when we pass in 3, what happens there? Right? So what happens when we call 3? So in this case here, what we'll do is we'll check. Is 3 equivalent to 1? It's not. So we're going to go right back here. What we're going to do is make 3 be what we multiply by. So 3 times. And then we're going to next call the expand factorial function. But this time we're going to pass in 3 minus 1. And so in this case, when we pass in 3 minus 1 here, that 3 minus 1 as an expression is actually going to be 2. Okay, so what we're seeing is 3 times when we call this expand factorial, whatever gets returned once we call expand factorial with the second value. Now we're going to move on to the next line here. So we're going to go in with 2. When we look at this process here and we look to see, all right, so we're at 4 times a certain value. We have our initial call, then we have our next range call here, where it's going to be 3 times some value. What else is going to happen at this point here when we check? Is 2 equivalent to 1? It's not. So here again, we have 2 times our next call, which is going to be expand underscore factorial, and it's going to be n minus 1 again, but this time it's going to be 2 minus 1. And that expression that 2 minus 1 is actually just going to be passing in 1. Okay, so when we actually now call the expand factorial and we pass in 1 here, we got to have our second or third closing parentheses here. Now we want to check to see, when we call this function with 1 in it, is 1 equivalent to 1? It is. So it's actually going to return 1. And if you notice specifically in this example, because we're using f string as a value to see what that looks like, it's actually going to concatenate the return value, which is why we're returning a stringed value. If we were using this for numbers, you would obviously just return 1 and also make sure that whatever value you have is going to be stored in a number and it's not going to be in a string, right? But in this case, it's going to return 1. So what we're actually going to see happen is we're going to have our recursive kind of trace back here. So we'll see this being 4 times 3 times 2 times, and in this case here, this return call, it's going to return 1. We know it's returning 1 here. So in this case, what actually happens, and I'm going to go through the process of tracing back here, is it's now going to have where we return 1, it's going to say 1 times 2 times 3 times 4, and we get our factorial version of our results returned back here. And then what you should get is it's equal to 24. This is what I was looking for this specific question. If you did it correctly and you were tracing through the process to understand how recursive functions work. Okay, so when we look at this, we know this is the process of recursive calls. We have an initiated call first originally to stand up with this, expand factorial n. Then we have where it does call this function, but with the value -1, with the next value -1, with the nth value -1. Each time the problem gets smaller and smaller until we hit the direct value here of n being equivalent to 1, which is our base case. So this is what I was expecting for question number 2 inside of this section here, because I did give you the code and the whole process was to actually pass in 4 and write down that process there. So not just writing equals 24, but the whole process is what I was looking for. You don't have to do as detailed as this, but you could, make the function shorter and just pass. And so at least I understand that you understand the process of recursive call. That's what I was looking for here. Put in a bit of effort there. So now that we have this process here, the next thing that I'm going to do here is comment this out, is we're going to move on to the next question here. Save. Okay. And that's going to be question number 4 and 5. This is going to be both questions here. Or actually, sorry, question number 3. My apologies. We're on 3. All right. So in this case here, when you look at this code, this is what it initiated. You're getting some input from the user, and I was hoping at least this would help you kind of review and understand code that you haven't seen or that you've seen before. And we know that the input function in Python is going to return a string. So in this case, we also see that it converts that string into an input and it stores that into n. Let's say we're actually tracing through this, and instead of us using the string version, we want to use the actual value, the numerical version. So we know that we wanted to convert that to being 4. So let's say that we actually did input 4 in there. Now, this function or this next line here is going to print out factorial is, and it's going to print out this last value, which is 24. And that's right, because this is what we want at least to see at the end here. So in this case, it passes and it calls the factorial function, passing in 4. So let's go ahead and define the factorial function here. And again, we already have our n assigned to 4 there. All right, so here we're going to define the function here. Okay, and in this case, when we're looking at this factorial function here, this we're going to call it factorial. And we're going to pass in n here, and then we're going to have a colon. So in this case, since we're actually going to be going over both the iterative and the recursive call, I know that it calls factorial, but we're going to assume that it calls it twice here. We're going to call factorial I, and then we're also going to call, or we're going to have a function called, define a function called factorial R. We're going to pass in n there. All right, so now that we've set this up here the way that we would like, I'm going to go ahead and make sure that we have a main function here that we can actually call these functions with the value that we have and actually see the results when we call it. So we're going to do question 3 here. Just put a comment here. Well, I didn't want to run it, so it's fine. Question 1 and 2 above. All right. Okay, so now that we have this process, we know that we're going to need to initiate the call with our main function here, with our function call. All right. All right, so now let's get started in actually writing our iterative factorial function versus our recursive factorial function. So the first thing I'm actually going to do is I want to actually write my factorial function, since that's the one that we currently have already given to us. But this time, we don't want it to return a string, and we don't want it to be in a string. So the first thing I'm going to look at here is I want to see what the base case is. And in the instructions here, I said, find the base case. Factorial of 1 is 1. This is a direct value here. So we know that with 1, it's going to return 1. So in this case, when we use our factorial value or using our base case to write our base case here, we're actually just going to have if n is equivalent to 1. This is going to be our base case. We want to return 1 because we know that that's always going to be the very last item that gets returned each time we're using factorial here. So now that we have this here, we have our base case, we now need to have our recursive call, our recursive call or our recursive case. And when we looked at, or at least understood, what a recursive case is, if we have our base case, that's the one that stops the infinite loop, it stops the function from running. The recursive case allows for part of the, I messed that up. The recursive case actually allows us to have part of the function, here, where it solves a smaller or simpler version of the exact same function by calling itself. So if we're looking here at the number value that we're passing in -1, we know at least from watching the code that we had to the left there, that our recursive call is going to be n-1. So we see we have our n-1 here. So we know that that's what's going to get included in that recursive call because it makes our case smaller and smaller each time. But the difference that we see here for the actual string version is that we had it in a string and we had n times and then another string value of what gets returned. But we don't want that. We want the numerical value there. So what we're going to do is actually just place inside of there a return statement, and we're going to have our nth value without a string times, and then we're going to call factorial r, passing in n-1. Now this here is our recursive call. So I'm going to actually place this over here. And this is our recursive case here. Yeah. This is our base case and our recursive case, but this here, this section here that's calling this function over and over and over again is that recursive call. So we know that each time it's going to be structured just like this because prior to that we went through this whole process. So now what we need to do is test it out. Does this work with the value that we passed in? So I'm going to comment out, or I'm going to save this actually because that pass will remove that. And we're going to go ahead and run this. Make sure I have no issues up above. Line 1, do I have something? We have pass here. I gotta pause this. It's not just this. All right, just had to fix that. All right, so now that we're in here and we want to run this file up, I'm glad I stopped that because we do need to print it out since it does return a value. So what we're going to do here is print around our function call here. Or if you feel more comfortable, you can assign a value to that and print that value out. But we're going to print out this call, and I'm just going to put equals, or we're going to have 4 factorial, equals, and we're just going to have some return value here. All right. So I'm using the comma because this is not concatenating anything to it. We just want to have this value associated to whatever gets returned because it's not a string, it's a numerical value. So now I'm going to save my file and run it. So now we see 4 factorial is equal to 24. So we do know that we did this correctly, we processed this right, and we also did our recursive function right. So now the next thing we're going to actually do is now our iterative function. What does a recursive call if this is the, what does an iterative function look like if this is the recursive factorial function? We know that we're going to have some value equaling 1, and we know that we are going to have to iterate through some values. So when we look at what iterate is, we usually think about using loops, whereas recursive version is just calling itself over and over again, right? So in this case here, what we're actually going to do is we're going to start with our result. We're going to have a variable here called result, and we're going to start with that equaling 1. So we're going to do result equals 1 here. Now, in this case, if we have result equaling 1, the next thing we want to do is actually be able to kind of loop through those values from 1 to n, including n though, because we want to include that last result of 4. So what would we do here if it needs to be using a for loop? Think about that process. So in this case here, we have 4, and we're going to have our variable I. You can name it whatever you want. In this case, I just have it I, and this I is going to be associated to every value in that range sequence. So I'm going to say for every I in range of, and we're going to start with 1, and then we're going to have n plus 1, so that we're going to place that expression n plus 1 there, so it includes 4 when we actually run it. So now we have the values from 1 to 4 that will get included. The next thing we want to actually do is multiply the results by each other, because here we see it's going to be 4 times 3 times 2 times 1. Or if we pass in 5, 5 times 4 times 3 times 2 times 1. So in this case here, what we're going to do is just have result equal result times I. You can think of this as similarly to how we have done incrementing or decrementing, where we add 1 to a value, or we add or we subtract 1 from a value. In this case, we're just multiplying I, whatever value that is, to 1. So if we're looking at this from that perspective, and I'll go through that really quickly. Let's just finish up this section here. What we're going to do lastly, we're going to get rid of pass, and we're going to put return result. Because eventually what gets stored inside of result will be the final result of our iterative values. So we know what the first time we call the for loop here. Comment. I originally here, and actually I'll probably put it at the bottom to make it easier. All right, so I, at the very first standpoint, is not going to be 0. It's going to be 1 here. So we're going to assign I to being 1. And we initialize it as 1 here, so that whenever it does call, because when you do 1 times 0, it gives you that value that, or 0. But in this case, we want to start at 1, so 1 times 1 is always going to be that 1 value there. So we have 1 times 1, and that gets stored here. So originally we had 1, now we're saying 1 times 1, and that gives us 1. So it pretty much overrides that and puts 1 there again. Now, the next thing we're going to do here is we're going to go to the next value. So we're going to have I is going to be equal to 2. So now what we should have here is we have in here where our value originally was 1. Oops. And then we have the result, which is 1, and then we have the result times the variable I, which is holding 2 because this is the second time we've run it. All right, so what happens here is in result, it updates that value to being 2 now, because 1 times 2 is 2. Now we're going to go the next time around, because I is not finished yet. We haven't met this condition, which essentially is just going to be starting from 1 and going to 5, not including 5, because that's how range works. All right, so now the second time we have it here, we have I is equal to 3. All right, so now we look in here. It originally has 2, so we know that, but remember how computers work is what's on the right is getting assigned to what's on the left, not the other way around in math. So I'm using this as an example to show you in memory what's stored in there at the present is 2, but it gets overridden. So in this case here, whatever is in result, which is 2, then we're going to times it by I, which is 3. So 2 times 3, what is that value? That actually is going to be 6. So we're going to update the variable result, and the value that gets stored in there is 6. All right. So the next thing we're going to do here is we're going to go back up here. We're looking at the range. Okay, the next item we're looking at is 4, when I equals 4. Okay, so here we know what was originally in result is 6. So we're going to have 6 times 4 in this case. And so 6 times 4 we know is going to be 24. So it's going to update that result variable that we had there, and it's going to give us 24. And that's great. That's the value that we want. But it doesn't just return there. What it does, again in range, is it goes up to range. Remember, it doesn't include the stopping value. Remember, when we're dealing with range, we have where it starts, it stops, and then it has a stepping. And by default, the step is 1. So if we wanted to add more to it, we could add 2 if we wanted to. But in this case, we're not. We're using the default value. We know the start is by default 0, so that's why we started the range to be at 1, so that it starts where we want it to be and end where we want it to be. Now, since n plus 1 is not included in range, it doesn't even update. It doesn't even want to go through that condition. It breaks out of that for loop. So now it breaks out of this for loop here because it doesn't include 5. Now what happens here is it goes to return result. Because result has been updated to be 25, it's going to or 24, it's going to return 24 here. So all it is simply is just initializing our result to start with 1 to get us the initial value here. And then, and also for us to be able to utilize our result variable inside of this loop here, and then be able to return it properly, then it gets updated each time it goes through this for loop. This is the iterative factorial function. And then it returns 24 there. So when we call this function, it's going to return 24, so we need to have a print statement. And I'm just going to actually assign it to a variable called result. And you could just do what I have below if you wanted to, but to show you the different versions again, for review process at this point, we're just going to have result, comma, result is going to be in the front. We're going to have our 4 factorial equals, and we're going to close it out with quotes and then have our comma here, result. And here I'm just going to place inside of here iterative function. And then here I'm just going to have recursive function. All right. So now when we actually use this, when we actually run this, what we got is both of them were correctly. We know that we executed both of them right, but the process is definitely quite about the same size even. But where we want to understand when you should actually use each at least in this case. So if we're looking at, I'm just going to comment or get rid of this really quickly up here. When we're looking at, move this over. It's easier to see the code. All right. When we're looking at this process here, they're about the same number of lines here, right? So what makes one better than the other, or when would you use one over the other? So we know that iterative with the for loop is more efficient in Python. There's no extra calling back in the stack like we would do here where it calls those functions, then it has to return back the information each time. But it is also very much so better to use the iterative version here for a lot more larger numbers. Like if you had like 1,000 or 1,000,000 or even more than that, this is better to use. But for recursive calls, it's a lot closer, or at least if you're trying to understand it from that mathematical definition of factorial, it's easier for you to be able to process it, to understand how it works. It's also good for teaching, which is why it's used so much in introductory coding classes to understand recursive functions. But it also is easier for you to see how it does break them into smaller subcomponents, whereas this one is just doing our process for us in a more multiplication way. So in this case, you will get to see the sub-problems being broken down a lot better. All right, so hopefully that helps you kind of understand or see the difference in iterative and recursive functions as it relates to, in this case, our factorial process. So now we're going to move on to question number 4 and 5 here. This is the iterative and the recursive version of this function. All right. 5 here. All right. So the next part of this process that we're going to look at is going to be using lists. We're going to look at how to sum a list iteratively and recursively. All right. So in this first case here, we see with the code, let's zoom in a bit. What happens here? We have a function called sum_list equals iterative. We also allow the user to enter in numbers separated by spaces here. And we're going to return that value into a variable called raw because that's raw data from the user. Then the next thing we're going to have is we're going to use our split function, and hopefully you remember split. What it does is it removes those spaces, in this case, if we had them in there, and it's going to just add in the value in 2 parts here. Now, the next thing we're going to do, because what happens here is this is a list of numbers at this point, removing the spaces. We also are going to declare our list of numbers, and this is an empty list here because we haven't added in anything yet. So we've set up our process where we clean our data. We've created an empty list to store in each item in that list. So in this case here, we're going to use our for loop to iteratively add in each item or each value associated to this part here, to this list of numbers. And in this case, it's a string because it's being inputted by the user and we didn't convert it to an integer yet. So it's a string of numbers. So that's why this is pretty much just doing for every item in this parts string list here. So then what we do is inside of our for loop here, we convert the specific item that we have to an integer and assign that to our number variable. You understand that this number is different from numbers with an S. And then what we do is whenever you want to add a value into a list, we know that we're going to use our append function. So essentially, again, like I said, this whole entire assignment was helped to also review, but also help you understand the difference between iterative and iterative and recursion. So we pass a number in here, and then that gets added into our empty list. And at this point, it's no longer an empty list. So the first item that is in there that the user entered in is going to get stored into our list. Now, the next part of this is that it actually calls some function called SumList, passing in our numbers list. But you'll notice that this is aligned right underneath the for loop. So it's only going to call this function once we get to the end of that, the list of numbers that the user had entered in. And that will be after it appends every item in that specific list there. But we notice now when we call it passing in a list of numbers, it's going to return some total. So we know inside of this function here, we want to return a value. And then we're actually going to print out that value. So now it's our job to actually work out the iterative function and the recursive function of this value. So we need to add in our value. So the first thing I'm going to do, again, like above, is I'm going to define my sum underscore list iteratively as well as recursively. So we're going to define it here, sum underscore list I, open close parentheses, colon, and I'm going to just type in pass there. Hopefully you remember what that was from our Code With Me session. It's just going to move past that function. And then we're going to actually do the same thing and for the iterative one. And we're going to do pass there. So for each of them, we know that we're going to take in a list of numbers. So I'm going to go ahead and type in numbers here. Same thing up here, numbers. But for us at the present, because this is just working it out through this process, I'm going to actually create a list of numbers, knowing that it needs to be an integer, and the actual name of the list needs to be numbers. So here, if you were writing it out, you would have numbers at least. You wouldn't have to worry about this, but if you're coding it out, you need to actually code it in this way. So numbers, and we're just going to add in like 3, 4, 5, 12, 10, and 8 here. These are some random numbers that I just came up with, okay? So now that we have numbers here as a list, we know that that's going to get passed into both. Let's go ahead and write out our iterative function here. And if you want, you can pause the video and see the instructions for what you could probably do for the recursive one. I give you what you think the base case should be, as well as how splitting each of them should look like splitting a list. And since we've gone through what lists, how you can actually go through each part of a list and display those lists, we're going to go through this again, kind of like as review. So in this first part, using the iterative function though, what we actually need is we need a total, a variable that's going to hold all of the values. Since we know we're going to have to use a for loop, so here we have for every num in numbers, and because numbers is a list, fortunately enough, our for loop can iterate through that list. Again, it's different from us using range, which is a sequence of numbers, but it's the same for loop, right? So it's saying for every number inside that list, you want to do something with that variable num, and we know that we have to return the total. So instead of you actually using the sum built-in function here, the point of this is to kind of show you how to do it iteratively. So we're going to actually create a variable called total and assign to it 0 to start off with. Similarly to what we did at the very top for this iterative function where we started with 1, so that when we did 1 times 1, it would return that 1 value that we need if we were passing in 1 as the factorial, or if we're passing in any other value, we know the end result is going to have 1 times whatever that value is. So in this case, when we're doing our summing of the list, we have the total value being 0 because we need to start somewhere. Now, inside of our for loop, we need to be able to total up those values. And how do you sum values? You just add to it. So if inside of total is 0, we're just going to have total plus equals num. the number that it goes through. Because we know that when we use our for loop, the first value that gets assigned to num is going to be 3. Then the second value is going to be num is going to be 4. Then the third value, where num is going to be 5. And then the fourth value, num is going to be 12. And then so on within this list, where we have num is then going to be 10. And then num is then going to be 8. So in this case here, again, we use our for loop to iterate through our list. And again, remember what I mentioned up above, this is where we call incrementing. This is where we're going to be adding that value to our total. And so in this case here, again, like I always mention in class, when we see total plus equal num, that's shorthanded for total equals total plus num here. So we know that that is the process of summing a value. And in this case, we know that total is always going to get updated each time, similarly to what we did here with recursion. Okay, so now that this updates total, each time it's going to add in there, it's going to have 3, then it's going to have 3 plus 4, then it's going to have 3 plus 4 plus 5, or in this case, 3 plus 7, or 7 plus 5, sorry. And then we have whatever 7 plus 5 is, 12, 12 plus 12, 24. Then we have 24 plus 10, which is 34. And then we have 34 plus 8. And so we know that that is going to be 44. Or, I mean, sorry, 42. All right. So in this case here, we know we also want to make sure that we return our total here. And it cannot be inside of the for loop because it needs to be after it has gone through the whole entire list. And essentially what's happening here is for every num inside of the list, when we get to the end of that list, it's going to break out of this for loop and we're going to return total here. All right. So now that we have this done, our iterative function done, let's go ahead and run this. And we know that this is going to be a global variable because it's not inside of any function here. So when we call it, it should work below here. Go ahead and do question 4 and 5. I'm going to call it here. And it returns the total. And I'm just going to do print iterative sum of list. And I'm just going to go ahead and place the list value in there so we can actually see. So I'm going to do \n and paste this here. All right. And then what we're actually going to do is we're also going to have another \n here. And I'm just going to do comma total. That way we can see it on a new line and kind of see that process. 2 here, space, equals this. All right, save. And we're going to run this file. And then we see here that it returns 42 because 3 plus 4 plus 5 plus 12 plus 10 plus 8 is 42. All right. So now in this case, we have our iterative list good. So hopefully when we actually make our recursive function, it will do the exact same thing. So what I'm going to do is actually I'm just going to copy this print statement and put a comment here for recursive function call and place the print at the bottom and update this to be recursive sum of list. And I will just put the total here as well. So we'll make it total equals. So we don't have to do too much changes here. All right. So now what we're going to do is do the recursive function version of this as well. So inside of here, we know it takes a list. And then when we look here in my instructions where I say define the base case, it should be an empty list that returns 0. Then we're going to split the list into the first item and the rest, and then describe how to recursively sum up the rest. So what that actually means here, what that actually means here is that we're first going to define our base case. So we know we're taking in a list of numbers, but we need to have our base case that will stop our recursive call here. So for this, I said it should be empty list. So we want to compare if numbers is equivalent to an empty list here. Then inside of this, we're going to return 0, because that's how we know that there's nothing else in there. Now, the next thing we have to do is actually the recursive call. And this is going to be our recursive case, the full list there. So with our recursive call, we know that we need to have a return statement because we're returning the value, whatever is in it, whatever gets returned at the end of our recursive call. So the first thing we want to look at is the first item in the list. But if we're trying to split the list each time, I'm going to go ahead and put this down here so we can see it a bit better. Plop it here. All right. Oops. Let's do it here. All right. So if we're trying to access our list value here, and we know that with the index, whenever we're using a list or whenever we're, going through a list or any process here, we start with the index being 0, 1, 2, 3, 4, and 5 here. All right. So in this case, we know if we're trying to do that recursive call and we're starting with the first item in that list, we have numbers, and we're going to access the first item in that list, which is 3, by having 0. If we want this to keep on calling each time until we get to the end of this list, we're going to be using our indexing here and our slicing. So in this case, we're going to need to call this function SumListR. So I'm going to copy the header without the define keyword and without the colon. And we're going to have sum_list_r with our list that we passed in, and we're going to have our open close square brackets. And we know that by accessing certain components of this list, we'll be able to guess the next item. If here we already have 3 associated, in this case, the very first time we call it, then the next thing we want to look at is we want to start at that index 1. And we know that if we start at index 1, in order to get to the end of the list, we can use colon, and it goes from 4 all the way down to 8, right? And so this is going to check to see the first time we call it. Get this here. Numbers is going to be equal to numbers is going to be starting with 4, 5, 12, 10, and 8 the second time we do this. Number 2. Okay, so the first time we call it, we pass in numbers, we move it on, and it adds 0 to a separate list, number 0 there, and we call SumList, only passing in the other half of it. Since it's not empty, it's then going to do the exact same thing again. And what is going to happen is we're going to first then have, I should probably put this over here, 3 plus this. So in this case here, when we call it a third time, what gets stored here is no longer 4, or no longer 4, it's going to be 4 here. And then we're going to next have numbers. Okay, I'll fast. We'll next have numbers, and then we'll have starting it at 5, because then the next index here is going to be 1 all the way down, because it keeps on breaking the problem down little by little. So we have 4 plus that function call. Okay, and so the next time we do it, it does it again. We have our number 4 call here, and what we're going to place here, we're going to place 5, because that's the first item each time inside of this list, plus, and then we're going to have that call, and the list that we pass in there is going to actually be from this one all the way down. So each time the index is going to be 0 for the first item, and it's going to shift it down where this is now going to be 1. Now we're going to call it again here. This time, what we're going to be adding in is going to be 12 plus, and we have our numbers is equal to, and then here we're going to have 10, comma 8. So it's just going to go through everything from 1 all the way to the end of that list. And then we're going to go back again. We have our number 6 here, and then we're going to have our 10 plus, and it's going to have our call to numbers, and we're only going to have here 8 to the end of the list. So now when we get to 8 to the end of the list, we're going to still do our next call here, 7. And we're going to add 8 here, 8 plus, and then here we're just going to have numbers is equal to an empty list at this point. So now that we're at this point here, we've had that 8, then we're calling this sum list R with an empty list. Then we're going to go to our if statement here, and it's going to check, is numbers equivalent to an empty list? It is. So now we're going to return 0. Right? So this is what gets returned here. Returns 0. So now what happens is from this call, we have 0 plus 8 plus 10 plus 12 plus 5 plus 4 plus 3. And all of these get to be returned. So at this point here, when we do return this, this is also return to that call, return to this call. The very last return, that's why I capitalized it here. The very last return here is 0, but it adds in all of those items. So what gets finally returned is going to be the very last return, which is that 4 plus 5 plus 12 plus 10 plus 8 plus 0. And we know that that is going to be 42. So that's pretty much how this section would actually be processed. Here. All right. Okay. So now that we have this recursive call, let's go ahead and check. Let's check to see if it actually works. And if we did it correctly, if we missed anything or anything like that. So we're going to go ahead and call it here. And then we're going to uncomment it out because we know we're going to store it in total. And I'm going to do this as total R, and this is going to be total I. Let me update this. All right, so let's run this. All right, so we see that we've done it correctly for both. So we know that it does the sum of both iteratively and also recursively. So again, we know the recursive works by taking the first element and adding the sum of the rest of the list as it returns. So when you would use each of these, when we have our recursive summing of the list or the iterative summing of the list, you'd use the iterative for it to be more clear, more efficient for very, very long lists, because you're using a for loop and this is going through each item of that list. And this is, you guys will get into this in other courses if you are choosing to keep with coding. And that would be kind of big O of N there based off of the numbers within that list. For the recursive one, though, what this is, it's good for learning recursion with list, or when you already are using recursion of a similar like list processing pattern, you would use the recursive function. Again, there are cases where recursive function is a lot more beneficial than using an iterative function, and this is more so, you'll see it in like sorting algorithms like quick sort and merge sort. But you won't get into that at the present. If you take 121, you will more than likely run into at least one of those sorting algorithms that has a recursive function call in it. All right, so the next thing we're going to go through here, and now that we kind of got the breakdown of it, I'm going to go a little bit faster to get through this process. But we're going to go through question exercise number 6. Since this was question 4 and 5, it was quite a lot to go through. All right. So in this case, for question number 6 here, we see that we have a function that we're calling countdown, and this is similar to the countdown function that I showed you guys on the last assignment or the previous assignment the week before. But we know that we're going to prompt the user to enter in some value to start the countdown from. We're converting that to an integer, and then we're calling our function countdown, passing in that numerical value that the user entered in. So we're going to go ahead and define that here. Define countdown, count underscore down I, open and close parentheses, passing in n, colon, and we're going to do pass there. Then we're going to define our other one, count underscore down R for the recursive function, passing in n as a parameter, colon, pass. So now that we have the structure of our functions, let's go ahead and start writing the code for this. So in this case here, let's go ahead and start a countdown by, let's say it's New Year's Eve or something, and we're starting it, everyone starts at 5, apparently. If you started early, you must be really, really happy that day. But here we do where we have n equals 5, right? So in this case here, what we're going to do for the iterative version is you can use, at least I've seen with this one, you can use multiple different ways. You can actually use a for loop if you wanted to and do a decrementing of it. But in this case, I'm going to show you how to use a while loop since, you know, we used for loop a lot throughout this, this code so far. So we're going to do while n is greater than 0. So we know whenever we're doing a countdown here, it's just going to be 5, 4, 3, 2, 1, and then that's when everyone's all like, Happy New Year's. Right? So in this case here, we know that the case for us to stop is going to be when n equals 0, because that means we're done counting. So inside of here, what do we need to do? Decrementing. So we're going to do n minus equals 1. And again, this is just n equals n minus 1. Right? And so for us, if we wanted to, we would just do a print statement where we print out n. And then at the very end here, underneath the while loop, we can print out, if you wanted to, string here. Let's do celebration. And we could probably just put Happy New Year, as I probably will not be able to say that to you guys at all this year. So, because you will be at home or wherever you are. So in this case here, we have Happy New Year, which should display after this while loop is executed. So for this case, I'm just going to do, we have N, and I'm just going to have over here dot, 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 so that we have that for each one, just to keep it the same. All right. Same. So this is the iterative version of the countdown function. For the most part, people found this pretty simple, but it works well. So we're going to go ahead and run this. Call this here, paste. And right above this, I'm just going to do a print statement. I'm just going to say iterative countdown, /n, and then colon space here, or caret space here. All right, so we're going to run this. And when we run this, we see below here, again, so it doesn't look so funny. Okay. So we see 4, 3, 2, 1, 0. Happy New Year. So we get to 0, it counts down, we have our Happy New Year, and it terminates from that while loop. And that's because we did num is greater than 0. If you wanted to, you could do num is greater than or equal to 0, so that it just runs it and doesn't print out the 0 for you there, and it just does that. Let me redo it. Oh, okay. Forgot about that. Yeah. We'll keep it at 0 for the time being because that is actually where I had this process here. It will go to -1 at that point, but if you didn't want to include that, you could pretty much just have an if statement just saying, because it does go up here and it checks the condition. If n is greater than 0, it's going to go ahead and do that while loop, and then it's going to actually even allow for n to be 0 because this does decrease it by 1 each time. So if you could have an if statement in here that just says if n is equal to 0, then you can push the print statement out and just put a break so that it breaks out of it before it prints it out. Or you can do a return statement. But in this case here, it is going to go from 43210, Happy New Year. So now that we have that process where we actually see the countdown, we see how it goes, the next thing we want to actually look at is the recursive function here. So in this case here, how recursive works, and we'll go back to the file. I expressed that you probably want to set your base case to when n becomes 0. Then you're going to describe each recursive call, and then you're going to print the current number and reduce it by 1. So if I didn't want this to show, I could also put this up here. Oops, didn't copy it. And it would not include that 0 if I wanted to. And here we see 5, 4, 3, 2, 1. Then we actually see it display out because it will decrease anyways just to get the 0, and the condition will break out. So there are a few different ways to approach this problem iteratively. For the recursive one, though, let's get into that. we're going to create our base case here. Okay, so for this, we're going to say if n is equal to 0, then inside of there, we're going to print out n, right? And now we need our recursive case. And for this, we want to make sure that we also, when we print out n, again, similarly to how we had to shift print from here upward to get it to be 0, or to remove 0 from here, we're actually going to place a return statement here. And this is to make sure that we break out before we see that 0 process there. But in our recursive call, or in this case, our recursive case, as well, we're just going to call count down r, passing in n minus 1 as a parameter. And because we have our base case, that base case is going to make sure that we break out of our recursive call over and over again. I'm going to save that. We're going to copy that function header there. I'm just going to copy this and place this here. And we're going to modify this. Instead of iterative, we're going to do recursive. Okay. Oops, I must not have put this in the right place. Let's see. Countdown R, we got the return, print n. I did put this in the wrong place. What we actually are going to do, because this does get into the base case, I said it correctly, just place it in the wrong place, is we actually have that return statement here. It's going to return and break out of that if statement and not even print out n. But what we want to do here is we want that print n to be right underneath our if statement there. Sorry about that. All right, yes. That's why we had 0 there originally. So now hopefully all we see again is our 4, 3, 2, 1, and then we don't see 0 as well if we do it in this way. If you wanted to see 0, you would go ahead and print out n inside of here as well. So we're going to not do that for right now. All right, so we see here 5, 4, 3, 2, 1. So let's go ahead and do the same thing here so we can make sure it's the same process, and then make sure we also have our final print statement here. All right, so if we put that print n there, then if we put that print Happy New Year inside of our base case, it will display that out at the very end. If you wanted to include the 0 there, you could, and just place it above that, and we get the 0, then the Happy New Year. But it's completely up to you how you do that. You just want to make sure that you have your return statement after the fact, and this is going to actually remove or get rid of or get us out of this section here without actually having to print n if you didn't want that. But what we know we're going to do is have our print statement aligned underneath that if statement. So this is the recursive call here. For both of them, we have our iterative and our recursive call, and they both do the same thing, and they both spit out the same thing. So we wrote it right, which is good. So in this case, what we actually see when people use each of these, again, where is that? The iterative is more simpler with loops. The recursive is just useful for, demonstration of recursion. But If your countdown is actually part of a much larger recursive process, then you would use the recursive one over the iterative one. So it depends on what you have in your actual application or how you want to use it. All right. Let's minimize split so I can see the next one. All right. So now that we're done with exercise 6, we're going to move on to counting items in a list. So before, we only counted an integer item. Here, where we counted a list of numbers to sum the value. Now here, what we're actually going to do is actually count just items within a list. So we're taking in information from a user separated by spaces. We're going to keep it a string, but we're going to use split to get rid of those spaces and return to this item pretty much a character or a list of values within a string. And we're going to be calling this function count underscore items. All right. Okay. What's this bit? So in this case, I'm going to just define this function as count underscore items here, and we're passing in items. And we're going to use the pass here. And then we're also, since this is supposed to be the iterative version here, we're also going to have def count items are. And we're going to pass in a list of items. We pass here. All right. So in this case, we know that we can create a list called items. And this list can hold any value because, again, list can be anything. We could have name, like Robin or Bob, and then we could also have numbers, 6, 6.5, which is a float, 8, and even true or false. List can hold many types, but how you handle it is dependent on you. We'll do 9.7 here. Okay. So we see here for this specific list, and didn't do point there. We see for this specific list here that we have different values that are associated here. And in this case, all right, so in the iterative, let's take a look, see. I missed something, 6, 6, 6, 6. Okay, here between the true and false, I missed a comma, so you want to make sure that you have that there. Make sure I got everything else. All right. So now that we have a list of items of any value in there, we're going to go ahead and go through the iterative version. So in this case here, we're going to have count, similarly to what we did above, where we had a variable total. We started with 0. In this case, we have a variable count, and we're starting with 0. Now again, we're going to use our for loop. So we're going to say for every I in items, that is the list that we're passing in. So for every item in that specific list here, we're going to increment. So we're going to add 1 to our variable count each time. So that's pretty much just going to be count equals count plus 1, and it's called incrementing. So each time it goes through each item in this list, it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. So we should see a return of 8 items from this list. So we're going to go ahead and do our return statement. And we're going to return count. Now, for things like this, whenever we're not actually using I, there is a process where you can actually use an underscore here, where it pretty much just says, okay, we're just using the for loop for the sequencing part to iterate through an item. We don't actually need to use this arbitrary number or variable there, so we can use an underscore. But for the sake of you guys learning a for loop and understanding that process, I'm just going to keep the I there. But we're not using the I at all in that process. So it's completely up to you how you want to do that process. now that you kind of know coding. So if you see that highlighted, it's because we're not using it. All right, so now this returns the actual count of the items within the list because we're just adding it up, adding each of the items up, as opposed to adding each number up. So you'll see the difference here where we're adding each number in that list up. So we had to keep the first one. And I know that there is a built-in sum function here, but this is all about iterative versus recursion. So now what we're going to do is test it out. We need to make sure that this iterative function works well. So we're going to go down here, do a print statement. Yep. All right, so we're going to do iterative counting items in a list. And I'm going to do this call here. And what I'm also going to do is provide the list so that I can see at least if it did what it's supposed to do. So we're going to do \n and paste that list there. And oops, we're just going to do, for me, I just like to do singles here just to make sure it doesn't interrupt with anything. But there is that / / thing that you can do within here. But to keep it simple for the video, I'm just going to change those quotes that I had. Second, let's see, so it's not be so difficult. Let's see where I'm at. Okay. So that way, at least for this part, we can at least see each of the items within that list. So I just did single quotes in there. But for some of you, I do know that you use the special characters so that it just can bypass that. All right, so now that we have this, what I'm going to do at the end of this list is do a / or / n. Then I'm going to have a space here for the actual value. So here we're going to, since it returns a value here, I'm just going to put this as count to keep with the variable we had at the top. So we're going to put count here. All right. And since we're going to be using the same process for the, oops, not this one. Since we're going to be using the same process for the recursive one, I'm just going to do the same thing below that, and I'm going to do recursive counting. Okay. And we'll just have here, actually place this below this so that I can actually get the count. There we go. And here we'll do our count, and we'll have our recursive call here, or our recursive function here. Okay. All right. So now that we have this process here, and we're going to run it to just make sure that it does count each item in that list. All right. And so we do see that it does print out. You haven't gotten there yet. It does print out 8 items in that list, so we know that the iterative one works. So let's go ahead and look at the recursive version. And we can take a look, see what was given to us to kind of try to see to use. So we're going to use an empty list as the base case. Then we're going to describe how to count the first item and then recursively count the rest. So for this, it's going to be quite similar to what we have above. The only difference is we actually don't care about counting. We don't care about counting the actual specific values within our list, so we're not going to use our index to access the items in the list. What we actually care about is just counting the value like we have here in the iterative one. So in this case, if it's expressed for you to have the base case here, I'm going to say if items is equivalent to an empty list here, we know that we're going to return 0. That's our base case when there's nothing left inside of that list. But we also need to have our recursive case. So we're going to return 1 plus, and this 1 here is coming from us adding 1 if the items are not empty. So we're just adding 1 each time. But what we're going to do is call our count items on this side. This is our recursive call. Oops. And then below this, we have our recursive case here. Right? This whole thing is a recursive case, and this part is our recursive call. All right. So in this case, we have items, but we want to include everything else inside of the items except for each time the very first or the very next item, the rest of the items here. So we're going to have our open close square brackets here. And what we're going to do with that is every time we call count underscore items are, we start at index 1. And this is going to count this item plus count the rest of the list each time we call. So each time we call, it's going to start with 1, add that, move on to the next one, add that, move that to the next one, add that. Again, similar to what we did above, right? So each time we call, it's going to be the next one that gets in there. So essentially, each time it's just going to keep on adding until we get to the empty list. And that's why this returns 0, because we don't want to add 9 to it. We just want to add 0 at the very end. We don't want to add 1 to it or anything like that. We just want it to keep on adding until we get to the end of the list. So to make sure that we did it right, we're going to put that recursive call there at the bottom and paste it here. And then we're going to make sure that we have our count, which will then update our print here. And we will see the results. And we see here that both of them work efficiently. If you feel like, for example, well, it would be the same since before, I can pretty much just change this to CT and it will be the same thing because count, what happens is it updates right here. I know I've gotten that question a few times in the past, so I just want to reiterate that here. All right. So now that we've finished with this part here, you know that you've done your recursively counting your items in your list, and also iteratively counted your items in the list. Where you use each is for the iterative version. This is just a standard way for counting items in a lot more efficient way. So we would see this section pretty often throughout programming. But again, for the recursive one, this is where we see it when we teach it or when we're working on understanding slices or even base cases. So this is slicing your list each time. All right. So the next item that we're actually going to look at is item 8. And this is where we reverse a string. So we've used strings before, but now you get to reverse it. And I know that there are built-in functions where you can reverse the function or where you can just reverse it easily. But in this case, we want to actually try it ourselves. So I'm going to minimize this and define our own. So here we're going to look at this. So here we have our reverse string interactive function. It takes in a string input here and we assign it to S. Then we're going to call some function called reverse underscore string and pass in our string in there. And if you remember what a string is, it pretty much is just a list of characters, like how we use a list above of items. It's just a list of characters. So here in this case, if I use name and I just placed in a random individual's name, I'll do Sophia here. What would happen would actually get showcased here if we did it as name as a list here. It would just be S O P H I, A. So when we look at this list, when we look at this string, this variable called name, storing our string Sophia, it is pretty much just a list of characters that this is how the computer interprets this. So we can use the same process. If we wanted to access A on this, we would just do name -1 to get the end of this list. Same process if we wanted to access this, -1. If you wanted to access S, you would do name 0. Same process for this. So when we are looking at the string, we're looking at similar process that we had with the other items. So I hope that makes some sense there. We're not going to actually use this here. We're going to use the same variable that's inside of here to keep it the same. So we're going to assign to S a name, and we'll call it Nico here, right? So we have Nico assigned to S. Now, the next thing we want to do is define the function. So we're going to have a reversed underscore string function here. Define reverse underscore string, and we're going to do I first, passing in S, colon, then pass. Then we're going to define reverse string R, passing in S, colon, and then we're going to pass. All right. So now in this case here, what we're going to do is do the iterative version first. So if we wanted to reverse this string here using the iterative version, we first need to have an initialized value. And anytime you want to initialize a string here in this case, that we're going to reuse later on, we're going to use an empty string so that we can start off with initializing it as an empty string. We're not initializing it as we did here with 0. It's going to be with an empty string. So we'll say reversed S equals an empty string. Oops, I need to, yeah. All right, there we go. It's in the right place. All right, so now that we have our empty string there, the next thing we're going to do is actually have our for loop. And so we're going to say for every char, and this is just going to be for every character. You could use I if you wanted to, X, or anything like that. This time we are going to use the variable in our for loop, so we want to make it something that later on, if you look back at your code, you understand what it's doing. So we're going to say for every character here inside of S, which is Nico, the list of the string here. Then inside of here, what we're going to do is we're going to have our reversed string, or reversed S, sorry, DS. And we're going to increment this or add to it based off of the character here. So in this case here, we're going to do char plus reverse underscore S. Now there's a reason why we didn't start off with, if you can imagine here, we usually do reverse S plus equals, and we could do char. That would be great if we weren't trying to reverse the string here. So the difference in this case is we're going to start off with the character that we have first, then we're going to add the reverse string each time. So I'm going to go ahead and show you that at the very top here. So in the reverse string here, let's say we have our empty string for the very first time we run it, and the first character or the first value that gets stored in char is going to be n. So we're going to have n here for the letter in Nico. Then we're going to have plus an empty string. So this is actually what gets updated into a reverse string here. So instead, it's just going to be n. Okay. Now, the next thing we're going to see happen here is when we move on to after char gets assigned, oops, let's do that as a comment. Char gets assigned n. The next thing we see is char is actually going to get assigned I, because that's the next item in this list of characters here. or this list of characters here. So what happens here is we see I plus N, and N is going to be at the end because it's in the reverse string. So this gets updated to be I and N. And we know whenever we see this, and this would be like, think of it as a space with that. This gets updated when we see this to actually being concatenation because we're using a string. Right? So this is different than us summing the value. We're actually adding the string or adding characters to a string here. Now, the next thing that we see when we go back to our for loop, after we're at I, it moves to the next item in that list, which will be K. So then char would be equal to K. All right, and then the next time we see here, we originally have I and N in there, and it will get overridden again as we go through this process. So the character here is going to be K plus, concatenate, I and N here. So what gets updated in here is we have K, I, and N. So then we're going to go back up to the for loop here, and we're going to assign to char the last item in that list, which is O, right? And so again, what happens here? We originally have kin, here. And then what we're going to do is have O here, and it's going to concatenate, add to the string of K, I, and capital N here. So essentially it gets updated here, so it's going to be O. So what happens is Nico gets reversed at the very end, and this is what we want to return. This is what we want to see. So at the end of this, once it gets to the end of our list or our character here, it's going to break out of this for loop, and we need to return the reversed S, which is the reverse string, and it will be what we have here, Okin. So in this case, I'm going to just move this out of here, copy, place this here, shift it. All right. And so this is what the iterative function looks like. We have our empty string, we have our for loop to iterate through our name, Nico, by each item. Then when it gets to the end of the list, we return the reverse string, which at the end is going to be Okin versus Nico. Now, in this case here, what we're going to see is that we need to, and this is often much more easier to understand and it's more efficient if you're wanting to reverse a string. But we're going to get into the recursion. And this is actually really, or the recursive function. And this is actually really good to help you understand a little bit more about strings and also lists at the same time, because you want to remember that a string is a list of characters or a sequence of characters here. Okay, so in this case here, we take in S, and we now need to be able to code this. And what did I give you? A clue in here about how to reverse a string. The base case is a string of length 0 or 1. And then we're going to describe removing the last character and recursively reversing the remainder. All right. Now for this one, I'm going to take a little bit more time to go through it with you because I think it may be a little bit more understandable through this process. So the very first thing we're going to do is we're going to have our if statement. We're going to say if the length S, and we know that when we're dealing with length, it is not how we access or how we use indexes with lists here. The length is the full total of that specific list. So for Sophia, I know we start with the index here being 0, 1, 2, 3, 4, 5, but the length of Sophia is actually going to be, let's go to that over here, is going to be 6 because there are 6 letters, right? So we're going to be looking at the length of Nico, which in this case is going to be 4 here. And we want to make sure that it is less than or equal to 1. And the reason we're doing that is the way that we're actually accessing or slicing the list of characters here in this case. So this is the base case here where the length is going to be 0 or 1. It's completely up to you how you do that because you can modify the way that you return the values in reverse if you want. But this is one way of doing it, what I'm showing you here in the video. So here we're just going to return S here. So that's going to be the last item there that we're going to be returning. All right, so in the next case here, after we've had our base case, we also need to have our recursive case, and then we also need to have our recursive call. All right, so in this case, we have our recursive case, and we know that we're going to be returning the reverse string. But the difference that we have here is we want to first return the end of this list here. So I'm going to go ahead and place this here so it's easier to see. And I'm going to just place it kind of like in a list form so that you can kind of see the process a little bit better. Okay. All right. And so we have positive indexing, but we also have negative indexing as well. So if you guys remember from when we went over lists and indexing, you can access them negatively as well. So we have -2, -3, and -4 here. All right. So now in this case, when we're actually looking at how to access the last letter inside of O, because we don't know how long this list is, it could be Sophia, it could be, any other value. If we started here with Sophia and we said, okay, we want to get to the end of the list, and that's S is the Sophia value, it would only start here at H. It wouldn't actually start with the end of the list. So what we want to do here is make sure we start with -1, so we always get to the end of every list. -1 would get us to A, -1 will get us to O, -1 will get us to the end of each character in that list. So in this case here, we're going to start here where S, -1, that's the value that we're going to add to it. So we're going to start off with it being 0. Or I mean O rather, O plus, then we need to have another call here. So we're going to call our reversed string function here. We're going to have a recursive call here. And we're going to be using our splicing here. So we're going to do open, close, square brackets. And let's say we want to get everything from the front of the list except for O. And here we're going to do -1. Yes. Let me see something. Okay. Okay. All right. I just wanted to make sure I did say that right because for some reason I thought I put 1 there. Okay. So yes, it's going to be -1 there. So we're going to start at the end of that list each time. But what's happening here in the splicing part is we're going to go to everything from the beginning, but instead of it being like how we had before, where we had, let me print this out here, where we had 1 going to the end of the list and it included everything from 1. How slicing works is when you're going from the end of the list, it's not going to include that last value. It's going to go with everything before that value. So in this case here, what we're seeing is it's going to be n plus, and we're going to have our reverse underscore string r call, and we're just passing in the list of n I k. So we're passing in that value, right? That's the first time we do it, the first time we run this return, because it's not at the length of being less than 1 yet. We see that the index is actually 0, 1, and 2. Let me go ahead and add that in so it's easy to see. 0, 1, 2. Okay. All right, so the next time we call this function with nik, the length is going to be 3. So we know that it's not going to meet our base case. So what are we going to do? We're going to call this again, but instead here we have our O, which is prior, but this is going to have our K plus now the call with just 0 and 1, and we're going to have the length being 2. Oops. Backspace 2. Okay. Yeah, so we have the length being 2 here. So now we know when we call this function and we pass in this, the length, is the length less than or equal to 1? It's not. So we're going to go ahead and do this process again. So this time here, that k plus whatever is here is actually going to be I plus our recursive call. We're going to get rid of that part of the list because we're going from the end of it and moving up. So anything in there. And this is going to be our index here. And the length is actually going to be 1 now. Now we can actually meet that base case there. Right? So when we call it this time around, when n, or the length is 1, when s is 1 here, we know that 1 is less than or equal to 1. Since 1 is equal to 1 here, we're going to just return s. So what happens here, 1, 2, 3, and then this one, sorry, is 2. Okay. All right. So what happens here in this case, we'll get to this point, is we have O plus K plus I plus what gets returned? The S. So whatever is in here, which is the list, N. So it's going to return N. And so each time this call, this one's going to return O here. Then we're going to look at this function. This one's returning the I. This one's returning the K. And then we also have our O. So at the very end, we have OKIN that gets returned here as the very last result. Right? So in this case here, what gets displayed out of what gets returned is -1. So you want to make sure this is -1 and it's on the right side of the colon when we're doing slicing. And you also want to make sure that when we're accessing the actual index, we're using -1 for that as well. And that's going to make sure each time we get to the end of the list, and for this one, not including the end of the list there. All right, so here I'm going to actually call this function below. Did I remember to call the others? Okay, so we'll call both of them below so we can actually see if they both work effectively. So we're going to have a print statement here, and they both return. Yep. So here we're going to do iterative reverse string /n, and I need to put that in quotes. And then here I'm just going to do a print statement and do my function call here. I'm going to make sure I have I for the first one. Then I'm going to copy this and just modify it a bit. So instead of being iterative reversed here, I'm just going to do recursive reversed here. Change my function call here to that R so it can be reversed. And then we'll actually see the actual output from here. Let's go ahead and see. So we see that both of them return the right value that we need. And so we know that we did both of them right. Nico turned to Okin. So hopefully that helps you refresh a little bit on strings and also lists, but also that you understand what the recursive call is and what the base case is in this case, how to use the length built-in function again, and also indexing, negative indexing. All right. So the next part of this is going to be the last item on our list, which is the Fibonacci sequence here. Now, before we move on, I do want to go through, because I did forget to go through the difference between the iterative and the recursive function here. Again, I said this was more easier to understand, the iterative reversing of the string. For the recursive one, it's just a good example for string recursion, slicing, and also showing the base case. You see here at least that they're pretty much about the same. It's pretty much about the same size in terms of the code. So there's not much difference there between this line and this line. They're literally about the same line. This one just has one less. So either or would have worked. All right. So the very next one that we're going to go through is the Fibonacci number sequence here. Fibonacci. All right. So we're going to look at what this is. So first things first, we take in some input from the user, we cast it or convert that to an integer, it gets stored into n, and then we call our function called fib here. So we know that it's also going to return some sequence because we're going to print out whatever gets returned here. So here I'm going to define the function fib I, open close parentheses, and we're going to take in n. Oops. We're going to pass that. Then we have our def. We're going to do fib r. And then we're going to have here another pass. And in this case here, if we wanted to do some Fibonacci sequence value here, I'm going to go ahead and put up, let's see, example. All right, so when we type in Fibonacci sequence here, the process of this is A plus B over A is equivalent to B plus C over B is equivalent to C plus D over C. Whenever you look at this, it's just going to be what was before, but a little bit different. And the Fibonacci sequence shows up in different aspects of your life. It's actually pretty beautiful mathematically, but I'm not going to get into that in this class here. So In this case here, what you just look at is this sequence and the structure. So in order to explain it a little bit better, I'm going to go ahead and showcase to you. This image is actually very understandable. We have A plus B, and then you want to divide that by whatever B is. So each time we're doing 0 plus 1 equals 1, then 1 plus 1 equals 2, then 1 plus 2 equals 3, and so on and so forth. So we're going to always add in the number prior to that to the actual value, and we'll get our Fibonacci sequence within this process by still using that specific formula to give us the golden ratio. If all right, and then we'll see here, this is the longer list of the Fibonacci sequence. I don't think it's going to show very well on the video just because it's so closed off, but it's a really cool sequence, and I at least hope that you guys run into it a few more times, and you more than likely will throughout the rest of the like if you have to take any math classes and stuff like that. So if, for example, you would like to kind of understand it a bit, or you want to at least make sure that you did it right in your mathematical classes or any of the classes that you're taking that include this, you could just create a function so that you can see the actual Fibonacci sequence as well. Anyways, that was on a tangent. Let's go ahead and get right into this here. All right. So in this case here, when we look at the Fibonacci sequence, I'm going to just minimize this so we can see the instructions here. What I say to do, and we'll get to the instructions for the recursion, but for the iterative process here, it's going to be a little, so it's going to be a little bit similar to actually, where do we have it before? Kind of like the factorial, but instead of multiplying, each time we're going to be minusing one or minusing two, and we're going to have two recursive calls and two base cases for this. So what we're going to do is go down to the iterative version here, and I'm going to go ahead and get started. So for the very first part here, we're going to have if n is equivalent to 0 here, we're going to return 0. Sorry about that. All right, so we have if n is equivalent to 0, we're going to return 0. If n is equivalent to 1, we're going to return 1. Now, this part is kind of writing in terms of the actual sum of the process. I'm going to actually write the function here so you can kind of see it. You may have seen this before in any of your other classes here, but we have, if we pass in a numerical value, in this case n here, we can do with that function f minus or n minus 1 plus f where n minus 2 here. And this is for whenever n is greater than or equal to 2. This is pretty much the function that you'll probably come across whenever you're looking at the Fibonacci sequence, because the first two numbers are defined as, let me pop this here. When f is 0, it's equivalent to 0, and then here we have when f is 1, it's equivalent to 1. All right, so then that means the very next step, if we were to actually process this a little bit, we would have the next one would be when f is 2. Move this a little bit over. Here, then we would have f being here 1 plus f being over here 0 because it's n minus 2 here. And that would be where we have equals 1 plus 0, and we start with the first number 1. And then we continue on with this where it would be 2, 3, 5, and 8. So I'll actually go through that with you a little bit because it's not the most intuitive thing to know. F and 2 here, yes, okay, plus F and 1, and we're going to do 1 plus 1. Easier to see. So we have 2. And actually, I'm going to pause the video and add a little bit more so that we can actually see it for both the iterative and the recursive function. All right, so here you'll notice that in this case, at any step, you only ever actually need the last 2 numbers to get the next one. So we have where we have 0 and 1, 1, and then 1 and 1 and 2, and then 2 and 1, and then 3. And so you'll see the process get repeated in that sequence. And we have that A plus B there. So we start off with A being 0, B being 1, and this is going to represent that F of 0 or F of 1, and then we move towards one step in the sequence. So we're going to be looking at N minus 1 or N minus 2 in this case, but the next Fibonacci number is always going to be that A plus B. Then we shift to the old B, becomes the new A. So in this case, we have A and then B. So here we have A plus B. Then we have 1. So the old B becomes the new A. And then we have A plus B becomes the new B. So this then becomes B in that case here. So in this case, again, we have A plus B. B is now going to be 2. A is now going to be 1. And so we have that whole entire process that allows for us to have our Fibonacci sequence here. So that's why we're using the cases and even in the iterative function of being N is equivalent to 0, returning 0, and if N is equivalent to 1, returning 1. So in this case, let's go ahead and look into A comma B here. So like I mentioned in class, you can either choose to assign the variables on the same line like you kind of have learned throughout the semester, or if you prefer to keep them all about the same, you can do A equals 0 and B equals 1 in that way. But to make it a little bit shorter so that we can see it all on one line, I'm just going to use them all on the same space here. So we're going to assign A to 0 and 1 to B. Now, the next thing we're actually going to do is have our for loop. So we're going to be using our for loop using I, but again, we're not actually going to use I. So here in this case, you can choose to use the underscore, but I'm just going to use I in this case in range. And in this case, since we already have the value returning 0, already have the value returning 1, we've already assigned A and B to their starting 0 and 1 value. Because range starts the default at 0, we're going to make sure that we start at 2. We want to start at the next item because this is for any nth greater than 2. The next part of this is going to be our N plus 1. Right? And this is just going to make sure, again, like we had above, where we want to include the nth value that we're passing in. So we're going to have to make sure we add 1 to it. So in this case here, what we're going to do, because if you remember in my explanation, we're actually going to assign to A what was originally in B, which in this case would be 1. Let me go ahead and show that in comments so it's easier also for you guys to see. So we assign A to B. We're assigning B to A, actually, sorry. And then the next one we're going to do is we're going to assign to B A plus B. So in this case, I'm going to do a comma, and I'm going to assign A plus B to our B value. So this is going to update the value here. All right. Now that we have this, the very next thing we're going to do after it actually goes through that for loop, we're just going to return B each time because that's going to keep on giving us that value that we need next. Right? So in this case, that's all that was kind of required for this Fibonacci sequence iterative version here. All right, and so what we're going to do is actually just call this here below. Print slash n here. And then we're going to just call it inside of this function. And it's going to be whatever we last assigned to n, which I believe is 5. But let's go ahead and make it a little bit, what number? Let's go ahead and make it up to, we'll go ahead and make it up to 10 here. Actually, we'll keep it here and just update it below. Makes life a little bit easier until n equals 10, so we can keep it the same. All right, so now the next thing we're going to do is we're going to update, or we're going to modify our recursive, we're going to add into our recursive function here. So in this case, when we define the base case, we want to define it in the same way. We're going to define it where n is equivalent to 0, and we're going to return 0, and n is equivalent to 1, and we're going to return 1. Then we're going to describe how the recursive call should be. And again, this specific recursive function is very similar to the mathematical representation of it. So what we're actually going to have here is we have two base cases. So base case número uno, and then we have base case número dos. There, we got two different base cases. The first one is going to be if n is equivalent to 0, we're going to return 0. Then we have our next one. If n is equivalent to 1, then we're going to return 1. Right. So now the next thing we have to do is just have our recursive calls. And we're going to have two. So in this case, we're going to do return. And we're going to call our fib_r function, passing in n minus 1. And then we're also going to add to that our fib, our function, passing in n minus 2 here. So in this case here, we see that we have two recursive calls, two base cases, and the actual function is a little bit shorter. So if we get rid of this process here, plot this up here, and this process here, right? It's actually here we have a few lines of code, whereas this one is also very short. You know, it's not as many lines of code, and it's not necessarily worried about specifically doing 0 to 1 with the A and the B. We're focused specifically on just the nth value. So in this case here, you know, the Fibonacci or the recursive call is actually, it's not as efficient for more larger values. So if we were trying to do like, you know, the biggest value that they have here, which you can't really see, to get like to the very last number, it wouldn't be very good for optimization here without actually optimizing the memory part. But it is good for understanding it with the mathematical definition of a Fibonacci sequence. So to get that. But the iterative version is a lot better, more memory efficient. Like you save more memory on your computer because you don't have to deal with the double recursive calls and the trace backing of that. But again, this is a lot better if you're trying to understand the Fibonacci sequence. And pretty much we teach a recursion with this as well as the factorial function. Okay, so I'm going to just copy this here and we're going to paste it below here. And I'm just going to copy this. And we're going to do the recursive call, and I'm just going to make sure I have the exact same thing. Things happen. Paste that in there. And so we have two different functions calling two different things. And I think in the end, I'm just going to make sure I have a new line there for each one. So at least for this one, so we don't actually see, so we can separate the two. And all right. And look. This is more so for formatting now for you guys to actually see when I run it. So now that we have this, let's go ahead and run the code to make sure that we have the right details here. So we have, when we do the Fibonacci of 10, that's going to be that's going to be number 55 here. So let's go ahead and look for things here. All right. So when we look at the 10th number here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This shows us the 10th value in that Fibonacci sequence here, which is 55. So whenever we pass an n, we're looking for the 10th value. If, for example, you wanted to print out each of the tracebacks, you could actually just print out each time it returns a call there, if that's what you would like to do. But in this case, we only just want to see if they both have or at least return the 10th item there. If we wanted, for example, number 21 here, we would just change this value to be 8, save it, and then we know that we'll see the output to be 21 because that is the 8th item in the Fibonacci sequence here. So now that you've kind of gone through this process, I'm really hoping that this helped you not only understand recursion, but also helps refresh your memory on a lot of different components that we've used throughout the semester here. So once you're done here, just because some people don't necessarily remember how to upload their file into, or upload their assignments into Canvas, I'm just going to copy the path in Visual Studio Code if you have Windows, or if you don't have Windows, you're just going to click on Start Assignment. You can even drag your assignment from your file location, or here I can just click on this, and then here I will click on the actual path here. Get rid of this. And then here we'll see Lab 10, Recursive this, open it up. And then your file should be right inside of there. So hopefully this helped you kind of understand the process of recursion and how it works a little bit better. Feel free to let me know if you have any questions, and you're just going to press Submit Assignment. And then you're all done for this here. All right. Wishing you the best and have a great rest of your day. Take care.